last section of linear relation. Fill in the blanks for me. An object is in, yep, motion. Good. An object is in motion when its distance from, uh, James? Oh, because? Oh, okay, yeah, okay. Okay. So make sure you sign out in the office. Okay. Reference point is changing. Speed is speed when given direction is called uh, Johnson. Velocity. Right. You learned this. You learned this in science class. So the only difference between speed and velocity is velocity you include direction as well. Okay. And then Joshua, what would number 3 be? Speed, right? So speed is. Do you guys remember the formula for speed? Yeah, DST. So speed equals distance divided by time. You will need to know this on the test. Okay. Okay, but it's nothing new. You know, speed is a calculation between distance versus time. Okay. So looking at this right here, number 4. This is actually good practice for your assignment too. Okay, which one shows two runner running at the same speed? Kavya, the last one. Why? Because it's parallel, and what can you say about their slope? The same slope. Oh, now didn't we do this yesterday? Okay. What about number 5? Which one? So this one, sorry, same slope. Okay. Which one starts off 10-meter ahead? Who had a head start? James. The first one. What did you look at? The y-intercept, right? So the y-intercept in this case, this one had a head start. Okay. So now looking at this number 6 right here, um, you have to pay attention to the axis titles right here. Distance and time. These are distance and time graph. 90% of the time of the motion graphs that you see are going to be distance versus time graphs. So uh, when we look at these are all distance from home, and your home is not just at this corner right here. Your home, or wherever you're starting from, your starting place is all along this x-axis. So all along here, this is home. All right. So if you start off at home and then you go like this, how would you describe this graph in terms of distance and time? Yep, Kasia?
The longer the distance, the more time it takes.
Okay, and then so which one would represent that? So is the car driving at a constant or increasing? It's constant, right? So this first one tells you that your car is traveling at a constant speed. So for example, after 1 kilometer, it takes me one 100 kilometers for 1 hour, 200 kilometers in 2 hours, 300 kilometers in 3 hours. So that's why this shows that your speed is the constant. Speed constant is constantly increasing. Okay. Now, what about this one then? This one is a tricky one. Kavya?
3.
Okay, Kavya says 3. The car speed is decreasing. Jeffrey.
The car is coming back.
Coming back, right? It's 4. Why? Because remember, this is distance time graph. So this is the distance away from home. You're coming back towards home. So this is you're coming back. So going back. Oh, sorry. I wrote the wrong reason here. My bad. This should say going, going away and coming back towards home. Okay. Because this is distance. So this is distance leaving away from home at a constant speed. This is coming back towards home at a constant speed.
Oh.
Yeah. Okay. Remember, this is home. Home.
What's the entire
Home. Entire x-axis. That's right. The entire x-axis. Because this is distance away from home. So what about C then? Joshua? The car is stopped. Good. Whenever it's a distance time graph, the horizontal line means it's stopped. Okay. Now, if you're thinking, why is stop not just a dot? Why is I thought it's stop? Why is it not just a dot right here? Person? Yeah, right. Just like if you're at a traffic light, you're stopped at the traffic light, time still goes on. Right? So you don't just suddenly the whole world freezes. Okay, if the whole world freezes, then yeah, it's a dot. But otherwise, time keep going. You're 50 kilometer away from home. After a minute, you're still 50 kilometer away from home. Right? So then the last one, this one, notice your line is it's not constant speed for sure because it's not a straight line. It's a curve and it actually slows down right here. So the speed of your car is slowing down. So because it's not, so if it's like this, then you know it's a constant speed. If it's like this, that means you're going really fast. If it's flat, if it suddenly becomes flat, it means that you're slowing down. So think of like the steepness of the line. Notice it's flat, so it means that you're slowing down. Okay, now let's do some analysis. Let's say Ashley, she's riding her bike to visit Maria. Sorry about the photocopy. Yeah, so Ashley is visiting Maria. And you see three segments right here. Okay, so A, B, and C. Okay, you have it on your page too. Your page will look, your diagram on your page looks better. Okay. So in the first 4 minutes from A to B, she was riding at a constant speed. What was her speed? Speed equals distance divided by time. So, Parsha. Okay, how did you calculate that? How did you calculate that? Okay, so from A to B, how far did she travel? From A to B, what's the distance there, Parsha? 800. And then how long did it take her? And so when you divide it, you get 200. If I write that on the test, will I get full mark? What unit should it be? Person? Meters, not just meters, but meters per minute. Good. Right? Because it's a speed. Speed, you guys know, kilometers per hour, meters per minute, meters per second is like your unit rate. You have to have the both units. Okay. What about the entire trip from A to C? How far did she travel for the whole trip? Jeffrey. 160 meters per minute. Okay, so 1600 in total, and it took her 10 minutes. So when you divide it, you get 160 meter per minute. Good. Okay, what was her average velocity for the whole trip? So remember the difference between speed and velocity? No. Direction. What direction was she going? We. How do you know that's east? How do you know that's northeast? What if she likes eating shredded wheat? No, I'm kidding. No, we never talk about north, east, south, west. in a graph like this, nobody said this has to be north. So
That's how it works. But that's east. That's how it works. It's northeast.
where does it?
Yeah, northeast. No, where?
Okay, well, the directly east part is just to throw you guys off. In a graph, you should never talk about northeast, southwest, but instead, where did she start off from? Where did she start? Location wise. Location wise, where does she start? Where? What is this again?
Home.
Home. All right. So now, if I want to give it a direction, I could say she's 160 meters per minute going on away from home, running away from home. Or what else could I say? Where was she going?
On a run. On a trip. Her friend's house. No.
Yeah, on a trip to her friend's house, which is Maria's house. So like towards Maria's house. So on the test, you could say, yeah, you could say she's running away from home towards Maria's house. Okay, that's direction. Okay. So actually, she stopped to tell her other friend that she's running away from home. How long? How long did she talk for, and where? How far away was she when she did that? Katya?
So she was 800 meters away.
Good. 800 meters away from home. Good.
Talking for 1
And talked
for 4 minutes.
for.
4 minutes.
Okay. Isn't it 8 minutes?
No.
No, that's right, because you're only looking at this segment, right? Oh, sorry. This is supposed to be C and then D. My bad. Yeah. So she was only talking from B to C right here, this segment. So this was only for 4 minutes. Okay. Now, what if I add an extra line like this? What does that mean?
That means she came back home.
Exactly, right. That means she came back home. Now, would you just say she walked home?
She went like took a jet.
Yeah, she took a jet. Yes, that's right. The steeper the line, the faster you went. So if the line was really flat like this, that means she took forever to walk home. She decided that I better go home. I don't want to run away anymore. Or she realized, yeah, home is nice, and then or her parents found her and drove her home. Okay. Uh, okay. Number 11. This one. So number 11, is this the exact same question as number 6? Did I make a mistake and photocopy the same question? Am I that bad? am I am I that bad to you guys? Okay, well that's not it. No. It's speed and time. Good recognition, Cheryl. Oh, but the fourth one is on the bottom. Yeah. Okay, so this is a total different. Your answer to all of these are going to be totally different because this is a speed versus time graph. As I said, 90% of the time you're going to get distance time graph, but in case that 10% comes up on EQAO, you need to know why they're tricking you. Okay?
Are you going to give us that? The speed and time?
Oh, well, we are going over it now.
Is this stuff you on the assignment?
No, not on the assignment, but on next week's test. Okay, so James. Hi, this graph right here, graph E. What's happening? It is accelerating because the speed is increasing. Increasing. Alright, because this is a speed versus time graph. So as time goes, what happens to your speed? It's increasing. Alright, what about this one? Jeffrey? Yeah, so you see the difference between the number 6 and number 11 now? The speed is decreasing. Okay, Nikon, graph G, this one. What's happening to your speed? It's the same. Good. So this is 6. Speed stays the same. And then the last one, if it's right here, Katya? Oh, what's the speed of this line?
Oh wait, no, not 8. I mean 5.
5. Right. The speed right here is at 0. Right. So because speed is 0. So pay attention to the axis, the name on the axis, because in a distance time graph and a speed times graph, the characteristic of your line varies very differently. All right. So, oh, sorry. Okay, Fossil. Okay, Albert, Bob, and Charlie are having a race. All right. So looking at these three right here, which one of them won the race? They're all stickmans. Albert, you think Albert? Why do you think Albert won? Why did Albert win? Didn't Charlie win? He has the furthest line. Why did Albert win? Least time, right. Albert only took 12 minutes. So least time. In fact, Charlie was slowpoke. Okay. Why did Charles take so long? Jeff, Yara? Because he stopped. You see this horizontal line? As we said, when all horizontal line means they stop in a distance time graph. How long did wait, How long did Charles stop for? Yara, how long did Charles stop for? Close. Close. So from here to here only. So from 8 to 13.
It's 12 seconds.
Oh, Charlie.
It's seconds, not minutes.
Oh. Well, the shoelaces were untied. Alright, Charlie's Charlie. 5 seconds. 5 seconds. What? Yeah, the shoe fell off. Alright, how long did Bob take to finish the whole race? 14 seconds. Now is that good time or a bad time? I know I have some runners here. Cheryl, I know you do track. Yeah. Okay. What's your speed for 100 meter? What's your time? 14 seconds? I'm sure you got timed. What is yours? 13.06? Alright. Anybody else? Owen? I think you do track too, right? What was your time? 12.5. Ooh, okay. So, anyone know the world record? Huh? 9.58 is who's that? Oh, right. Alright, so if you can run faster than so probably hit 9.58. So this is Usain Bolt. Oh my god. That's it. Yeah. I made him faster. That's Bolt. Okay. And what was his average speed? So if you, again, speed is distance divided by time. Okay.
8.
Yeah. Okay. So where's the other page? Okay. So what about what is this one then? Oh, I skipped the page 24. It's okay. Because I don't want you guys to get confused with the speed time. Okay, what about this one? What are my axes? What are the title? Uh, Kavya?
Distance from home is kilometers.
Right, so another distance time graph, but notice here, I'm actually using time. So like not seconds, but actual time. Okay, so at what time did Pete start his journey?
30 p.m.
Okay, 1:30 p.m. Thank you. Let's put our hands up. Okay. Okay, 2:30, Yara. Uh, where did he take a break? How far away from home was he when he took a break? 10 kilometers. Good. How long did he take the break for during that time? So again, I'm only looking from here to here. Okay, so be careful with the units right here. Every box is how much? 15 minutes, right? So from 2:30 to 3, that's 30 minutes. Right? So be very careful with the axes. And then, so for the whole journey, how far did he travel? 36, right? That's right. So on the way there, he took 18, and then on the way back, he took another 18. So in total, that's 36 kilometers in 6.5 hours. No, 5.5 hours. Okay. Okay, so last year when I did this section, I actually had like group activity, and then like I had you guys make up stories with graphs like this. Who's my creative writers here? Okay, James. Is it gonna be appropriate though? Because I am recording this video. Okay, so So James, thanks for sharing your story. It's very creative, but I do need these 4 factors when you give your answer to get the full marks. So can somebody give a second story including those? Okay, Kavya.
So, what's his name? Pete.
Yeah, Pete.
Travel 10 kilometers in half an hour. I mean, half an hour.
Uh,
An hour.
1 hour. 1 hour. 1 hour.
Hour.
Yeah.
And then he ran into his friend. That same thing, and then he stayed there for another half an hour.
Okay.
And then he realized that he had to run really fast, so he ran 18 kilometers up. No, he ran 8 kilometers up in an hour. No.
Okay.
Oh,
No, it's okay. Keep going. Keep going. I'm just writing down some notes.
and then he ran another 8 kilometers in
Basil, you're next.
an hour. And then, he ran in the front for like another hour.
Okay.
And then jogged back home for he jogged for 18 kilometers in like
2 hours. Okay. So I like how many friends Pete has. Okay. But remember right here, Kavya said he ran 8 kilometers up. How do you run 8 kilometers up?
flying.
And then does this mean that he fell off the cliff?
Go down.
Alright, so whenever you give these answers, there's never up or down. There's no mountains or rooftop or hill or anything. We use the words away or towards. Remember, away from home, towards somewhere. All right, so you were missing the direction for that. All right. Huh? You can, but if he was, oh, that's actually a very good question. Okay, if let's say Pete's friend's house is on top of a mountain, what would the speed be more likely? What would happen to the speed? It would slow down. So instead of a steep line, you'll actually see a flatter line because the speed is slowing down.
So if that were the case, would you tell us?
No, you have to know that it's not up or down anything. You always use the word away or toward.
Away and toward.
Yeah. Okay. So on the test, you're gonna get a table. I'm gonna ask you guys to analyze each segment of these. So make sure you do talk about the direction and then talk about this distance, speed, and time. Okay. Okay. Let's just finish this last part off so that you guys don't have to worry about any homework over the weekend. This one, the temperature starts at 0 and keeps rising. Which one shows this? B, right? Because it's given. it's given right there. Okay. The temperature stays the same for a time and then falls. C. C. The temperature rises and then it drops dramatically. Okay. The temperature rises and then falls quickly. Nathan. I wonder why I called on you. Temperature rises and then falls quickly. Rise temperature. Oh, sorry. Where am I? Oh, sorry. I wrote the wrong thing. This one was D. Yeah, D. Temperature stays the same and then falls. I read the wrong one, right? Yeah, sorry. Temperature rise and then falls quickly. Rise and then falls quickly. This is D. And then so Nathan, you can answer this one. Temperature is always the same. The A, right? Temperature stays the same. Okay, Faisal then. The temperature rises, stays the same, and then falls. F, right? And then the last one, Parshan. Temperature rises, stays the same, and then rises to boiling. D. Sorry, E. I don't know my alphabets today. Yeah.
What would it's not here, but what would be the thing for oh it is there. B, never mind.
Yeah. Okay, so this one is a temperature versus time graph. So in any of these, it could be a distance time, it could be a temperature time, it could be a speed time. You have to make sure you read the titles carefully. Okay,